Hey guys, welcome. Another session of Revise for a Prize, the game show where we're going to revise the topic, we're going to try a quiz on the topic, and I'm going to give you guys the chance to win a prize. Same prize this week as last week. We got Amazon vouchers, 2 Amazon vouchers. So one for £5 if you're second place, and if you're first place, if you do get the top of the podium, you're going to win £25. Remember, we are trying to up the prizes here, but for that, we need more people. We need more people in these streams. We're trying to reach 50 at any one point, and we will up the prizes. I did so last time. I promised you guys last time, and I'll do it again if we do reach 50. So invite your friends, spam the likes, and yeah, we'll start with the revision session. I can see a good community. I can see the regulars here. We got Roya Akbari. Hello. Jada Martin, Philip. What's that? Niche. Hi guys. Hi. How is everyone doing? Who's feeling confident? Maleka, good to see you. Does anyone feel like they're going to win today? How are we all feeling? Last week, was it a close one? I think last week was a one where there was a last minute winner, right? I think so. Start earlier, please. 8:30. Sorry, 8:30 is the earliest I can do because I teach. I basically teach, and this is literally the earliest time I can do. Otherwise, I would. But the live on Sundays are earlier. They're at 7:45. The ones with Nav. But I would if I can. Roy Akbari says, I'm feeling confident. Literally revising covalent bonding. Love it. Love to hear it, guys. Covalent bonding is an all right topic, I say. It's a paper one chemistry topic. Not too bad. There's harder ones. There's moles. There's electrolysis, which are both horrible. Mohammed, how are you? Good to see you. Phil, third place last time. Unlucky. Hopefully this time. I got a feeling this time, maybe you get first or second. This is your first time. Welcome. Everyone let Hashim know how it goes. We're doing revision. We're going to do a revision session. You take part in the revision session, answer my questions, take a screenshot of you participating in the chat, and then do the quiz at the end. And once we've done that, the top two will win a prize. So we've got 2 prizes today. Like I said, Amazon gift vouchers. Is this AQA GCSE combined? So, yep. So what we're doing today is relevant for combined. It's relevant for foundation. It's relevant for triple and higher as well. Sorry. So foundation, higher, triple, combined is pretty much relevant for everyone doing their GCSEs. How do we do the quiz? I'm going to show you the link of the Kahoot, and you guys can join. I'll give you the code. You just need to download the app or go on the website, the Kahoot website. Just Google it, and then you can do it. You're triple. You got this. Nice to hear that, Jada Martin. Right. Isn't covalent bonding hard? Hopefully, by the end of today, you're going to find it a bit easier. All right. So, as usual, guys, here on the right-hand side, we've got our website, flashrevisionlab.com, where I'm going to be opening up the notes that we have on it. I remember I've gone through the whole syllabus, spec point by spec point, and made these notes, tried to make them as easily digestible as possible, easy to read, along with exam questions. And it's been broken down topic by topic. So we're going into topic 2 today, bonding and structure. And we're not going through ionic bonding. We're going to go through ionic, not ionic compounds either. We're going through covalent bonding, covalent compounds, and allotropes of carbon. So basically these 3 sections, all right? So that's everything to do with covalent bonding there. So how about we get started? So what I'm going to do first, I'm going to give you guys a quick summary. So remember, topic 2 is all to do with bonding. There's 3 types, and you can see here in the table, we've got 3 types. Ionic, let me write these down. So feel free to make notes as well, guys. It's all about learning. Yes, you do get prizes, but at the end of the day, I want you guys to get the best marks for your GCSEs. So we've got ionic, we've got covalent, we've got metallic. Does anyone know any differences between them? Let me know in the chat if you know any of the differences between ionic, covalent, and metallic bonding. The main difference is what causes these different types of bondings, what types of elements cause this. Hi, Potato Cars. Hi, Hannah. Good to see you guys again. Ionic, thank you, Hannah, is between metals and non-metals. Let's write that down. So this is metals and non-metals. Covalent is non-metals only. And metallic is in the name, metals only. So that's how you figure it out. All right. So if you look at periodic table, you can figure out what's a metal or a non-metal. If it's on the left-hand side, then it's a metal. If it's on the right-hand side, it's a non-metal. Guys, maybe might be a good idea to have a periodic table in front of you when you're doing the quiz. Just a quick hint there. It might help. Okay. So what we're doing is covalent bonding. Okay. So covalent bonding, we're going to open up that topic and we're going to see the notes on it. It's a type of bonding that occurs between non-metals, and it's all to do with the sharing of electrons. Okay, sharing of electrons. So ionic is not sharing of electrons. Ionic is transfer of electrons. So one atom transfers an electron to another atom and it forms ions. Okay, we're not going to talk about that today. That's a whole new topic. Another topic, sorry. Covalent bonding is when these atoms share their electrons. So the aim of them sharing their electrons, why do they want to share their electrons? The reason for that is because it makes their structure stable. Makes their structure stable. Because it basically gives them a full outer shell. Every atom always wants to get a full outer shell. That's their aim because it makes them stable, makes them happy, and that's their aim. That's what you got to remember in these types of topics. Right. Ionic helps held by electrostatic forces between non-metals and metals. Covalence between non-metals held by intermolecular forces. You're almost right, Mohammed. Okay, this is one thing I'm going to make sure you guys don't get mixed up with, okay? Electrostatic and intermolecular, okay? Those are two different things. And I'm going to actually talk about that now. Does anyone know the difference between electrostatic forces and intermolecular forces? It's in the name, kind of. Intermolecular, electrostatic. People get mixed up between these two all the time. Electrostatic, covalent bonding has electrostatic attraction. So basically, covalent bonding has both, or covalent compounds can have both. Covalent bonding is electrostatic, okay? So intermolecular is in the name. Well done, Iman. It is between molecules. It's in the name, right? Intermolecular, between molecules. And we're going to see that in a diagram in a second. Between molecules, we have intermolecular. Electrostatic. Electro is like electric charges. So it's between charges. So it's between something that's like positively charged and negatively charged. So if you have something positively charged, like a proton, and something negatively charged, like an electron, they're like magnets. They attract each other. That's electrostatic attraction. So between positive and negative charges. Yep. Electrostatics between atoms, not quite, Hannah, not quite. Intermolecular is between is bonds between molecules. Exactly. Thank you. Thank you. So is intermolecular part of metallic bonding? Asks SKZ. No, it's not. Metallic bonding has no intermolecular. The only time you see intermolecular forces is in covalent bonding in simple molecular substances, which I'm going to go through in a second. Okay, we will come back to this in a second. So what actually is a covalent bond? Covalent bond is when you have two non-metals. So you can see here we got hydrogen and hydrogen. All right. So if we drew a single, let's look at, I'm just going to talk about the hydrogen first. So hydrogen and hydrogen, if I draw a single hydrogen atom, it's only got one electron, right? So you got to think in your head, it's got one electron. How does it become stable? it basically needs another electron from somewhere. So if it had another electron, then it'll be nice and happy, it'll be nice and stable. Where does it get that electron from? Well, it needs that from another hydrogen. Okay, so another hydrogen. So basically these two join up to form this image that we have here. All right. And what you can see here is two hydrogen atoms covalently bonded. And you can see that because the two shells overlap. So if they overlap like that, like if they look like a Venn diagram, it means it's covalent bonding. And what's holding the covalent bond together is electrostatic attraction. Because what you've got here in the middle is shared electrons. So this electron at the top and this electron here basically get shared between the two, like so. And we've got the shared pair of electrons there. And because we've got a nucleus here, remember nucleus are positively charged, electrons are negatively charged. So you've got something negatively charged, that's going to be attracted to something positively charged. And that's also going to be attracted to the other thing that's positively charged on the other side. So all of these things are like stuck together like magnets, which holds the whole molecule together. All right. How can you know if an... Okay, I'll answer that in a second, Arthur. If I don't, then ask me again. Ask me again. Okay. So we got the covalent bond in the middle, and they're held together by electrostatic attraction. Okay, because this is positive, this is negative, and this is positive. So they're all attracting each other. This whole thing here is a covalent bond. Everything in the middle is a covalent bond. It's the sharing of electrons. So you've got the shared electrons in the middle. So that's a dot and cross diagram. A simpler way of drawing this is called a displayed formula, where you just draw the two atoms, have a line in between representing the covalent bond. So that's a covalent bond, and that represents it. Much simpler way of writing it. And here we've got loads of different ones. So these are all the ones that you need to know in your spec, okay? And let me double check. Let me go in the spec tab. And I think they've got a list somewhere. There we go. See, it says students should be able to draw dot and cross diagrams for molecules of, and they've given us a list. So what I've done in the notes is I've literally drawn all the ones that you need to know. That doesn't mean they can't ask you other ones. That's applying your knowledge. But these are the ones they say you should definitely, as a minimum, be able to draw. Okay, so go through these and make sure you can draw all of these. So we got chlorine here. We got oxygen and nitrogen. So look at the difference between these three. Let's zoom in a bit. Look at chlorine at the top, oxygen in the middle, nitrogen is at the bottom. Can anyone tell me what's the difference between these three? What's the difference between their covalent bonding between the atoms? How do you access that revision sheet? It's not a revision sheet. It's our website. All of these notes are free, by the way, if you just sign up onto it. It's flashrevisionlab.com. flashrevisionlab.com. Exactly. Well done, Hannah and Mohammed. So chlorine only has one pair of electrons. Every pair of electrons you have is one covalent bond. So the top one has one covalent bond. The second one has a double covalent bond because it has 4 electrons. The third one has a triple bond because it's got 6 electrons in the middle. So all you do is you count how many pairs they have, and that's how many bonds they have. And you can see that here. Look at their displayed formula. This is a single bond because it had one pair. This had 2 pairs. It had 4 electrons. So that's a double bond. And nitrogen had 3 pairs. So it was a triple bond. Exactly. So nitrogen was stronger. All right. So other ones which are important, water. We've got 2 single bonds. Then we've got ammonia here, which is NH3. You can see up here in ammonia, it's got like a pair that's not used. That's called a lone pair. And then we've got methane here. Okay, so those are just the ones that you need to memorize. Yes, double bonds are stronger. Good question. Good question. So we've talked about two different ways to show covalent bonds. One is dot and cross diagrams. The second one is displayed formula, which is a simpler one. Now you've also got 3D models. So this, you'll never get asked to draw in the exam. They will show you, and they'll ask you a question like, tell me or give us the formula of this molecule. And you can see here, the orange one, the one in the middle, is nitrogen. And there's one nitrogen. So we would write N, one nitrogen. We don't put a 1 down. We don't put 1 down like that. So we'll put N, H, and how many H's are there? There's 3 white spheres. So that's NH3, those types of questions. So, yep, well done, guys. That's the type of questions that you'll get on 3D 3D structures. And I'm pretty sure there are some exam questions on this somewhere if you look through them. Oh, there we go. First one here. Look at that. So they've given here. This is literally an exam question that came up like a few years ago. They've labeled the chlorine atom, they've labeled the oxygen atom. Can anyone tell me, what do you think this formula is? What's the formula of this atom by looking at this? What's good about this diagram? Good question, Jada. I'm going to actually go through the good and the bad of each one because you need to know that. It shows the angles which the atoms interact with and are more visually. I wouldn't say that, Arthur. I wouldn't say it shows the angles. I wouldn't. I'll tell you what the advantages are. So people are putting CO4, not quite. No C, because it's chlorine, right? Chlorine is Cl. Is Cl. Oxygen is O. Okay, we just need to count them up now. Chlorine is these light gray spheres. And you can see there's 1, 2 light grays. So it's Cl2. And then we count how many oxygens there are. Those are the dark gray ones. 1, 2, 3, 4, 5, 6, 7. Cl2O7 is the answer for this. All right. So Cl2O7, and you can check the mark scheme. That's what it says. Cl2O7 is the answer. So yeah, if you want to revise topics, guys, just work through these question by question. Once you've done the notes, obviously, once you've gone through the content, and I guarantee it will help your exam practice so much. If you just go through this topic by topic, and you will just get better and better at it. All right. Never seen this before. Never seen the question or the website. If you haven't seen the question, then yeah, it came back. I think it was like a combined paper. If you've seen the website, definitely check it out after this live. Okay, so here, this is a table that tells you the advantages and disadvantages of each different structure. So we've got dot and cross, ball and stick model, and displayed formulas. And you can see the advantages and disadvantages. So like dot and cross diagrams, for example, it shows you the electrons. So you can see the electrons. So that's pretty good. You can see how many electrons are being shared. Whereas the other two, you can't see how many electrons there are. You can't see where the electrons come from. So that's an advantage. Disadvantage is quite tricky to draw these. It's much easier to draw a displayed formula. 3D model advantage, it tells you exactly how the molecule looks like. It shows its arrangement in 3D space. You can see, oh, okay, so this molecule actually has like this sort of pyramid shape. We call it a pyramidal shape. But it's very complicated to draw. And also you can't see the electrons. And then you got a displayed formula. Good thing about that is very easy to draw. But you can't see any electrons on it. You can't see the 3D structure of it. Okay. You're being spammed by ads. Sorry, that's YouTube for you. That's not me. I don't really have control of that. Just obviously skip them and then press the YouTube button, and then you'll jump to exactly where I am there. So yeah, that's the first part of covalent bonding. That's the theory behind covalent bonding. So now we're going to look at covalent compounds. So 3 types of covalent compounds we need to know. So remember these. We've got simple molecular, we've got giant covalent, and we've got metallic bonding. Not metallic, what am I talking about? Polymers. All right, you need to be able to identify which one's which. Simple molecular is basically ones that exist as molecules. They're all of these. All the ones I showed you are simple molecular. Hydrogen, chlorine, oxygen, nitrogen, hydrogen chloride, water, ammonia, methane. All right. And pretty much anything you can draw a dot and cross diagram for is simple molecular. Giant covalent. I'm going to give you a list of all the ones that you come across in your GCSEs. So you've got silicon dioxide, which I will show you here. Silicon dioxide is one that you need to know. And then there's all the allotropes of carbon, which I'm going to go in a second. So there's diamond, graphite. It's also graphene. Then the fullerenes, the two types of fullerenes that I'm going to go through in a second. So there's Buckminster fullerene and there's carbon nanotubes. Okay. And polymers, you barely get any questions on polymers in your exams. They're just like long chain molecules. Okay. So first thing I'm going to go through is simple molecular substances. Okay. So the first one. So the key thing about these simple molecular substances, they have a very low boiling point and melting point, and you need to know why. Let's look at this diagram very carefully. So what we've got here is a chlorine molecule, okay? So one of these spheres are atoms. So that's a chlorine atom. Here's another chlorine atom next to it. They're held together by a covalent bond. So between the atoms, there's a covalent bond. Covalent bonds are extremely strong. But between the molecules, so together, both of these chlorine atoms make a chlorine molecule. Between chlorine molecules, you have intermolecular forces. So know the difference between the two. So this is a covalent bond that's between the atoms, but between the molecules, you have intermolecular forces. And remember, a molecule is two or more atoms that are bonded together. Because we get to make exactly. So because the reason why they have low boiling points and melting points is because these intermolecular forces are very weak. They're very easy to break. They don't need much energy, so you can easily break them and boil these substances, okay? So that's why they have low boiling points. The bigger the molecule, the stronger the intermolecular forces. So they're still weak. So look at this example here. We got chlorine and we've got iodine. Iodine is much bigger than chlorine. The atoms are much bigger. So iodine has stronger intermolecular forces. So those forces between the molecules are much stronger in iodine than it is in chlorine. So that means it's slightly harder to break compared to chlorine. So that's why it has such a high boiling point. Look at that. It's 184 degrees for iodine, but for chlorine, it's only minus 34 degrees. It's very easy to break those chlorine bonds, but for iodine, you need much more energy. So the bigger the atom or the bigger the molecule, the stronger the intermolecular forces. All right, let's see what the chat is saying. When do I do these lives? Okay, so we got 2 lives. Well, actually, we do 5 lives per week. 2 of them are on YouTube for free, and the other 3 are FRL classes subscription. So those 3 are very structured classes which go through the whole of the science specification. They're done on a weekly basis. We go topic by topic and we just cover every single spec point. All right. These lives, these free lives on Wednesdays and on Sundays, 8:30 on Wednesdays and 7:45 on Sundays. We pick a topic, we do a quick revision session on it, like we're doing right now, and then we do a quiz at the end of it. All right. Those are the two things. What else we got? If in single bond, not much energy needed to overcome intermolecular forces. Yes, that's right. So intermolecular forces are always weak. Exactly, Hassan. Good question. Intermolecular forces are always weak, but if the molecule is bigger, they get stronger. Okay, they never become as strong as a covalent bond. Though covalent bonds are just like super strong. They can't get stronger than those. All right. Malika says quiz. All right, why don't we get you guys in the quiz before we carry on? Here it is. We've got game pin 1554278 before I carry on. And then we will start in about, let's say, about 10 minutes. I just want to go through the content. Make sure you guys are with it. Should I go faster through the content or slower? What do you guys think? How's the pace? I can go faster if you want. I just wanted you guys to get the best possible chance for the quiz. Let me know in the chat, guys. Do you want me to go faster or slower or the same? How's it? Malika says faster. Thank you, Hannah, for that. Faster. Dennis saying faster. All right. I'll do it. Okay, I'll speed up. We've only got 15 in here. We've got 6 people in the Kahoot. Ahmed says slower. I think the vote's for faster, so I will speed up and then we'll start the Kahoot soon. Nice. We've got 12 people in here. Graceful Camel. We got Brave Camel and Graceful Camel here. All right. Let's see who's going to win. Nice. Mohammed is Brave Camel. Malika is Graceful Camel. Cool. All right. Let's go back. I'll speed things up. So, simple molecular substances. Do they conduct electricity? No, they don't, because they don't have any free moving electrons or ions. So that's simple molecular substances. Next, we got the second thing, which is polymers. Polymers are like plastics. You can think of polymers as things with very, very, very big molecules. Okay, you can think of them as very long-chained molecules. They have intermolecular forces between the molecules, but covalent bonds between the atoms. Remember that. Between the atoms, it's covalent bonds. Between the molecules is intermolecular forces, and they are quite strong, those intermolecular forces, compared to the ones of simple molecular, so they need more energy to break. This is how you represent a polymer. Okay, you got the brackets around it with an N on the outside. Okay. Slow net is going to make you lose. Yeah, if you get like those questions where you got to drop the pin, faster internet does help, kind of, I think. Giant covalent structure. So giant covalent are large networks of covalent bonds. So the whole molecule has covalent bonds. Remember I said covalent bonds are the strongest one out of all the types of bonding. Covalent bonding is the strongest. So if all the bonds are covalent, it's going to take a lot of energy to break. So that is covalent compounds. So remember, on the website, once you've done a topic, you can just mark it as complete. It'll check it off and then it'll update your percentage. It basically tells you how much you've covered for each subject. Okay, last bit is allotropes of carbon. So what does an allotrope mean? Allotrope is different structures of the same element. So you need to know the allotropes of carbon. So that means it's based all the ones that you need to know. So I said diamond, graphite, graphene, fullerenes. All of those ones, they're all carbon, but they just have slightly different structures. Okay. Exactly. Yeah, they're made out of carbon, but diamond. But they all have different structures. Yes, exactly. So diamond, this is how diamond looks like. Look at that. It's a tetrahedral structure. We call that a tetrahedral structure. In diamond, every carbon atom is bonded to 4 other carbon atoms. Okay. It's very hard, like someone said. I don't remember, someone said it earlier. And it has an incredibly high melting point because a lot of energy is needed to break it. Can silicon dioxide conduct electricity? No, it can't. In order for something to conduct electricity, it needs free moving ions or free moving electrons. So one of those two. That has neither. Silicon dioxide doesn't have either. There's a list of things that are conduct electricity that you need to have for your GCSEs. So I'll give you the list. It's metals, graphite, graphene, and molten or aqueous ionic compounds. So those four things basically conduct electricity for different reasons, but I'm trying to think of it anymore. Those four things are the ones that conduct electricity. So that is diamond. It doesn't conduct electricity because it has no free moving electrons or ions. Graphite, on the other hand. So remember I said for diamond, each carbon atom is bonded to 4 other carbon atoms. Graphite, each carbon atom is bonded to 3 other carbon atoms. So they form this like hexagonal layers. And the layers are basically just stacked on top of each other. And because they're bonded to 3 other carbon atoms instead of 4, they have a delocalized electrons because one of the electrons on the outer shell are not used for bonding. And that means it can conduct electricity. And yes, well done. Hassan said it's used in pencils, exactly that, because the layers can slide off each other. It's also soft. It's used as like lubricant for machines because those layers can easily slide over each other. Okay, so things you need to remember: it conducts electricity because it's got delocalized electrons, and also it's soft as well. And yeah, each carbon atom is bonded to 3 other carbon atoms. Now, graphene and graphite, people get mixed up about all the time. Graphene is just one layer of graphite. So remember, graphite's got multiple layers. Graphene only has one of those layers. It's only a single layer of graphite. And it is a good conductor of heat and electricity as well because it's got delocalized electrons. Graphite is also a good conductor of electricity and heat. Is ionic bonding on the quiz? No, Dennis is not on the quiz. It's just covalent bonding today. But diamond can't because it has some high melting point, which is hard. So diamond has a high temperature, has a high melting point and boiling point. Yes. Then we've got fullerenes. So fullerenes, let me scroll down to fullerenes. Nearly done, nearly done. So they're molecules with hollow shapes. Hollow just means it's got like a gap in it. And basically they like can encapsulate other molecules, so they can hold other molecules in, and that makes them useful for like catalysts. 2 types of fullerenes you need to know. This one that looks like a football, that's called Buckminster fullerene. That's the name. And the formula for that is C60. So in a molecule of this, there are 60 different carbon atoms in them. All right. That's the only one you need to memorize in terms of the actual formula for it. That's C60. And then you've got carbon nanotubes, which are cylindrical. So they're like a cylinder shape. They have a very high length to diameter ratio. They also conduct heat and electricity. They have delocalized electrons. Sorry, that's another one that conducts electricity. Nanotubes, because yeah, each carbon atom is bonded to 3. And they're used for like things like tennis rackets because they have a high tensile strength. Let me see the chat. Isn't a Buckminster technically a simple molecule? Interesting, Arthur. That is good observation. It's like a complicated simple molecule. So it does exist as a molecule, but it's not very simple, right? It's got 60 different atoms in it. So that you can think of them as like polymers. They're very big molecules. So they do have intermolecular forces between the different balls, but within the carbon atoms, there are covalent bonds. So graphite and nanotubes are the only ones that can conduct electricity. Graphite, graphene, nanotubes in this topic, yes, But then there's also metals in metallic bonding and molten and aqueous ionic compounds in ionic bonding. Yeah. Do giant covalent structures also have intermolecular forces as graphene does, but why doesn't diamond? So yeah, yes, they do, but they're not very relevant. So they do have intermolecular forces because graphite is made up of these big sheets of these hexagonal rings. So between these sheets, between these layers, there are intermolecular forces. But when you melt it, you don't need to break them. You need to break the covalent bonds between them. That's why it's got such a high melting point. Diamond doesn't, because look at this structure. The whole thing is just one huge tetrahedral structure. It's just covalent bonds everywhere. There's no need for intermolecular forces because there are no like molecules. I hope that answers your question. Delocalized electrons. So Leon says delocalized electrons carry charge through structure, so can conduct electricity. Yes, exactly. All right, good, cool. Any other questions, guys? Let me know if there are any other questions. I think we're nearly ready to start. Yeah, we are. I'll give you guys another chance to answer ask some questions. I'll answer them. We got 16 people in the Kahoot. Let's see if there's any more else joining. Let me know. I will wait. Yeah, no worries. Good luck, Jada. Wish me luck. Yes, good luck. Hope it goes well. So we've got 17 in the Kahoot. I'll wait for maybe like 2 minutes, a minute or two. If anyone's got any other questions, like about revision or anything like that, then let me know. Drop it in the chat. So if you guys are thinking of joining FRL classes, we've got our next one on Friday. So that's in chemistry. So remember, those go through topics much more detail. It's not like this. We don't wish through it. And I don't ask people to speed me up. We like this topic, for example, took like a whole hour when I went through everything. We give you a workbook where you can follow everything I'm saying, write it down, and you have the workbooks as a revision guide after. So you print it out, you follow along, and yeah, it's very structured. So we're going through organic chemistry, if I remember correctly. Yeah, we did equilibrium. We're going through organic chemistry this Friday. FRL classes. So we got 3 plans. So to unlock the whole website, so that most of the website is free, but to unlock all of it is £4 a month. The classes for one subject is £11 a month. And then for all 3 sciences is £22 a month. So I think it comes up to like £2 per class or something really small like that, because in a month you get 12 classes, and it's £22. So it's just under £2 per class if you guys join. Which science are we doing on Sundays? Physics. Do you guys have a free school meal scheme? No, we don't, but we can. If you guys like drop me a DM or a message, then we can give you guys discounts like for like a month or 2. So if you are thinking of joining, drop me a DM on like TikTok or email help@flashrevisionlab.com, and yeah, we can give you guys like a discount trial or something. 26 people. Wow, 26 people. Is that the most we've had? If you win the Kahoot, do you win the prizes? Yes, if you get first place. So guys, remember the rules. Top 2 of the quiz will get a prize. First place will get a £25 Amazon voucher. Second place will get a £5 Amazon voucher. So the rules are, you should have been in that revision session. So not talking now, but should have been chatting in the revision session earlier, taken a screenshot. You still have a chance to do that. You can scroll up if you were in that. If you haven't, then that's fine. You can still do the quiz, but you won't win if you haven't taken part in the chat. So the whole aim is to get everyone to revise with us. Then we can reward them with a prize. And then if you do get on the podium, if you get top 2, then take a screenshot and email us. The email's right here, help@flashrevisionlab.com, and we'll send you your prize. Okay. Yes, Jada, you've been here from the beginning. That's good. 22 people live stream, 26 on Kahoot. Yeah, people are locking in, because in Kahoot, remember, it's all about the speed. So you want to answer the question as soon as possible. So some people, yeah, just because they're watching on their phone, they switch the Kahoot app. So that's why. Right, we got 29 people. This is probably the biggest one. I will get started. So remember, the first question is usually like a poll. So let's get started. Even if we do start and you join after, you can join after. And yeah. How to screenshot on laptop. It depends. If it's a Mac, it's a Shift Command 4. What if it's a PC, guys? I'm not sure. Does anyone know how do you screenshot on a PC? What grade are you aiming for in GCSE Science? Let me know in the chat. It's interesting to hear what everyone's aiming for. This isn't gonna get you a prize. If you put a 9, say I just want to hear what type of students we've got here. Hopefully we have a nice mix. 10. Mohammed says 10. That's what I like to hear. Yes. Nice. 9, 8. Okay. But yeah, everyone's got different aims. Some people are aiming for those top grades. Some people just want to pass. They're not interested. They just want to finish, get through science, and then do something else after. That's fine as well. I'm here to just help you wherever you are. So we got 29 answers. I think that means we've got everyone answering. Let's see what everyone said. 29 answers submitted. Let's show the answers. 789. Everyone's aiming for 789. Looks like, wow, look at that. 79 people aiming for a 9. We got 14%. 79 people, sorry, 79%. 14% aiming for 8 and 7% aiming for a 7. Okay, that's good, guys. That's good. Like that. I hate science, says Malika. Fair enough. I'm not one to judge. I'm just here to get you through those grades. All right. Are we ready to start, guys? Let me know in the chat. Spam the likes. Are you ready? If we're ready, I'm going to press the next button and we'll get started. Locked in. Yes. Good luck, guys. I wish you all the best. And remember to screenshot if you do. First question. Let's go. True or false? It's an easy one. Covalent bonding involves the sharing of electrons. Spam the answer. Look at that. Look at the speed on that. You're just tapping. Tap. Get it ready. First one. We always start with an easy one. We get a few people getting 1,000 on the first few and then they drop off. 28 answers. I think we had 30 people. There we go. 27 of you got it right. One of you unfortunately got it wrong. That was meant to be the easy one. Unlucky. Yes, covalent bonding is the sharing of electrons. That is the literal definition of it. There we go. We got the 2000s at the start. We always get these. Let's see how long they can stay up there for. They never do. You just spam the true side. Is it the left side? And then hope that you get 1,000, I think. Mohammed's on the podium. Right. Keep it up, Brave Camel. Yes, 3rd place. Try and let's see. 23rd. That's fine. We know one of our winners actually started off at 23rd and then they just kept creeping up. So keep it up. People do drop points. Let's go for the next one. Pin. Where is the covalent bond in this diagram? So move the pin to where the covalent bond is and press submit. Don't forget to press submit. This is a dot and cross diagram of hydrogen gas, H2. I showed you this in the revision session and I showed you where the covalent bond is. Remember that attraction that's there. The pin, you move it around. There we go. Look at that. No one got that wrong. I love it. Everyone got that right. Smashed it, guys. 30. Do you do art? Thank you. I do. I have all these diagrams. I do draw. I use a vector. What they're called? Vector art, and I draw them all using Illustrator. So all the diagrams that you see on the website, yeah, they're drawn by me. Not freehand though. Space out in the podium. Brave Camel. Wait, who was that? That was Mohammed, right? Well done. Keep it up. Thanks, Phil. Right. Arthur says cooking. Nice, nice. Let's go. Next one. Smart starfish stays in second place. Space owl. That was, who was it again? Space owl. Saw that somewhere. That is Deba. Yes. Keep it up, guys. Let's go. Next question. Quiz. What type of covalent bond is present in this molecule? Look at that molecule. Is it single, double, triple, or quadruple bond? Remember, I showed you what do you look at to decide whether it's a single, double, triple, or quadruple bond. You know what I'm liking? I'm liking that everyone's getting these right. Or like 30, pretty much everyone, almost everyone's getting this right. It means you guys have been revising in the class. Right, this one, not as many people got right. Fair enough. Fair enough. Let's just look at that diagram again. There are 6 electrons in the middle. Remember, I told you every pair is a bond. So because there's 6, that's 3 pairs. That's a triple bond. Nitrogen has a triple bond. Okay. How many questions? I think we've got about 12. So we've got about 9 more. So let's see how it's looking. Fearless Liger. Liger. Is it meant to be tiger? That has jumped up to first place. Brave Camel, second place. Nice. Maleka's 15th. Hannah's 25th. You tried to be quick and thought it said simple covalent. Yes, exactly. Yeah, I know what you mean. It was a type of covalent bond. All right, 26th. We don't mind. As long as you get something out of the revision session and from your wrong answers as well. Let's go. Next one. Type. Name this carbon allotrope. I think it's going to reveal itself slowly. All right. What do you guys think this is? We saw this one. Type it. Someone's typed it in. Yeah, I think you can guess it now. Look at that. Quick. Everyone's quick on their phones or wherever you're typing on your laptop. Is it faster to type on your laptop? Probably is, right? 21 answered. All right. Now we need to know. What is that? Not fullerene. No, Jade, unlucky. It's not fullerene. Remember, the fullerenes are the tubes. They're hollow inside. We got diamond. Yes, diamond is that one. Diamond. Unlucky. 12 of you got that right. 12 of you. It's diamond. It's got that tetrahedral shape. Fearless Liger still up there. Thrilling Narwhal. Who was that? That was someone here, right? Arthur. Nice. Jumped up to second. You're nearly getting that £5 Amazon voucher. Fearless Liger, you're on for that £25 voucher. Brave Camel, drop to third. Mohammed, you're really close though. You're only 30 behind. All right, are we ready for the next one? We need more type questions like this, Philip says. What do the rest of you think? More type questions or less type questions? I think there might be another one, you know. I'll let you answer this first and then I'll ask. More, less. It's more competitive. All right. I'll do that. All right, let's go. Quiz. Which of these carbon allotropes conduct electricity? I told you guys, yeah? So there was a few, but only one of these conduct electricity. And someone actually asked about one of these as well. So I went through all of them. Smashed it, guys. 22 of you smashed it. I said graphite. Remember, it's got those delocalized electrons. Silicon dioxide doesn't. Buckminster fullerene doesn't either. And diamond doesn't either. Yes. Let's see how the leaderboard's looking. It's the same up there. Brave Camel still chasing after the Narwhal. About 20 behind. Nearly there. Fearless Liger is up there. It's quite far up there. But remember, one mistake, and we've seen it before. One mistake, and they go crashing back down. So people are saying less. It's more about accuracy, not speed. Yes, it's a mix of accuracy and speed. So that's why I try to mix up the questions. I don't want it just to be multiple choice. I try to add some different elements to it, just to make it interesting. All right, let's go for the next one. 7 of 13. Why do simple molecular substances have low boiling points? I mentioned this as well. Why did they have low boiling points? Is it weak intermolecular forces, high molecular weight, ionic bonding, or strong covalent bonds? There's one weak, there's one word that gives it away, is the weak. If they're low boiling points, it means that it's easy to break those bonds. So it's very weak. The forces in it are very weak. It's weak intermolecular forces. Well done, guys. How is the leaderboard looking? Same, no movement. No one's budging. Everyone's just getting these right. 9 participants hit an answer streak of 6, and 9 of you have got nothing wrong, I think. How many more questions are there? I think we're past halfway. I'm going to press next and I'll tell you how many we're on. Ready? Let's go. 8 of 13. Slider. How many carbon atoms does one molecule of Buckminster fullerene have? There's a different one. Remember, I like to mix up the type of questions we have. Slide to the answer. 13 questions, Jada. We're nearly done. We're on question 8 of 13. Roy Akbari's put an answer down. Says, Ahmed, is it right? Is it right? They put 60. Someone put 70. Oh, unlucky, Ahmed. Is 60. Mohammed, sorry. Unlucky. Why was submit button so random? Yeah, it's always there. The submit button. You got to press that. If it's not multiple choice, you got to press the submit button. So do you do economics A level? No, I don't. Sorry, I don't. I didn't do it for A level either. Ah, you put 59. Unlucky. You were 1 away. You can't come back, says Jadine. 13. Maybe you can. I've got some tricky ones coming up. What did I pick? I picked maths, chemistry, and physics for A level. Maths, physics, and chemistry. They were all tricky. Look at that. Brave Camel. Brave Camel's jumped up to second. That was Mohammed, right? If you guys want to ask me about my A levels, then you can do after the quiz. I can talk to you about it. I'll stay behind for a few minutes after. How is like a first? It means they got 10, 40 every single time. What do you mean 10? Oh, 1040. No, it's how many is it? It's 9 questions. So they would be on 9,000 if they got all of them right? All right, let's see. Next one. Type answer. Which forces attract nuclei to shared electrons? Here's another typing one. Let's go. What is the type of force holding the covalent bond together? So that nucleus is attracted to the electrons in the middle. What's that called again? Remember, I said it. Do typos count as wrong? Yes, they do, unfortunately. We've got 2 answers here. We've got someone saying electrostatic, but someone saying intermolecular. It's not. It's electrostatic. It's electrostatic. 8 of you got that right. Big change here. Big change. Zealous Blackbird, Majestic Guana has jumped up to second and third. Okay, let's go to the next one. That's what you put, is it? You had to write electrostatic attraction. Oh, it should have been the answer was just electrostatic forces. It said what type of forces. So it was just electrostatic. All right, on to the next one. Quiz. What holds atoms together in a polymer chain? What holds atoms together? So those green ones. Not the green ones, sorry, the black ones. Is it covalent bonds? Is it intermolecular forces? Is it metallic bonds? Or is it ionic bonds? Which one is it? The answer was covalent bonds, not intermolecular forces. Intermolecular forces, guys, is between the molecules. Between the molecules, remember I said this is intermolecular forces. Between the bonds, or between the atoms, it's covalent bonds. Okay. Sorry, Ahmed, that's my bad. That's my bad. Next one. Let's see how the leaderboard is looking. Who's a zealous blackbird? Is that anyone in the chat? How many more questions? I think it's about 3 more or 2 more. I'll tell you. Let's go next and I'll tell you how many more. Slider, we got 3 more. How many covalent bonds do each carbon atom have in graphene? Each carbon atom has how many covalent bonds? Fearless Liger, yeah, they have been cooking. They weren't at the top at the start. I think someone dropped off at the end, and then they've just been getting everything right so far. Is it? Oh, loads of people made the mistakes. It's not 4. The answer's 3. Diamond has 4, but graphene has 3. Yes, graphite and graphene has 3. Again, if you were in the revision session, you would have remembered that that's what I said. In graphite and graphene, each carbon atom is bonded to 3. That's why it's got the delocalized electrons. Unlucky, unlucky. Okay, nearly done. 2 more questions. 2 more questions. Fearless Liger is way at the front. No stopping Fearless Liger, it doesn't look like, unless they get one wrong. Remember, if you get one wrong, just like those other 2 dropped off, anyone could drop off as well. Brave Camel, you've come back. 4th place. Come on, you can maybe make it. Remember, I think we got some harder questions coming up. Jada says it will lock in on Sunday. Yes. Try again on Sunday. Don't worry, we're doing this every Wednesday and Sunday, guys. Keep joining. And remember, if you don't win, it's still revision. You're still winning in that way, right? Okay, next up, last 2. Pin. It's another pin. Where are the intermolecular forces represented in this diagram? Take the pin, take it to the intermolecular force, drop it, press submit. You should know now. I said it already as well. In the polymer question, I don't want anyone getting this wrong. Please. What's the topic for Sunday? I'm not sure. We'll drop it on the story. So physics, what have we done so far? We've done electricity, right? We've done radiation. Are there any requests? Green one. Yes. Look at that. Oh, 2 people put the covalent bonds. Unlucky. It's the green dashes are the intermolecular forces. Well done for those of you who remembered. It's between the molecules, hence the name intermolecular. Electricity, we've done electricity molecular. Maybe we might do it again, like, I don't know, next month or something. You can watch that replay again if you want. You can go back and watch that replay. And you can see. Atmosphere, maybe we can do that in the next chemistry one. So physics is definitely on Sunday, but then after that we can see what to do after. Fearless Liger. Oh, Majestic Iguana is only 30 away. Before it was like, I think the gap was like 300. So there is a chance for that top spot. Majestic Iguana, is that anyone here? Fearless Liger, is that anyone here? I think these people are just locked in the quiz. Left, atmosphere. Okay, cool. Are we ready for the last one, guys? Last one, and then I'll stay behind like 2-3 minutes. If you guys got any questions about A levels, I'll give some quick answers. Let's go. Last question. Good luck. 13 of 13. Multi-select. Select more than one. Which of the following are covalent compounds? Okay, pick the ones that you think are covalent and press submit. How many are there? We don't know. It's multi-select. I'll put a periodic table there if you want to check. Remember I said it'll be useful to have a periodic table for this one, because how can you tell something's covalent? If they are 2 non-metals, it's covalent. If it's a non-metal and a metal, it's ionic. And if it's just a metal, it's metallic. So for covalent, you're looking for just metals. So we've got 3 there. We've got water, carbon dioxide, and silicon dioxide. Yes, says Phil. What happened? Did you get onto the did you get onto it? Did you win last minute? Let's see what the podium's saying. First one says brave camel. Oh, Phil. No, Mohammed. Majestic iguana. Who's that? Is that anyone here? And then, yeah, it must be the Liger, right? Fearless Liger. Well done, guys. Phil got second. Well done. Congratulations. You get the £5 Amazon voucher. Fearless Liger, you get the £25 voucher. Remember what to do, guys. Phil, I saw you in the chat as well. So take a screenshot of the chat. Take a screenshot of your Kahoot and send it to us. help@flashrevisionlab.com. And we will send you guys your Amazon voucher. We're going to do this again. Mohammed, he says, I never win. Don't worry, we're going to have loads of chances. Phil said that. Phil said that a few weeks back. I remember he got close. I think on Sunday. Did you get close or something? You got third or something once, right? And you got second place this time. So you can keep trying, guys. Remember, you don't lose anything by doing these quizzes. Phil, you got third before. Exactly. Congrats, says Hannah. That's what I like to hear. Well done. Oliver wants to ask me a question. Yes, you can ask a question. I'll stay behind for a few minutes if you guys got any questions. But yeah, rest of you, I'll see you on, well, if you're part of FRL classes, I'll see you on Friday for chemistry. And then next Wednesday for the quiz. Nav will be doing a quiz this Sunday as well at 7:45, so you can join that as well. Sunday visit redemption, says Phil. Dennis, see you on Friday. Phil, see you on Friday. Well done again. Remember to send the email. Same with Fearless Liger. Send us the email and we'll send you guys the voucher. Yes, Mohammed says you'll click the quiz next week. All right, guys, what's on Sunday? It's going to be some physics topic. I'm not sure what. I'll decide and I'll put it on the story on the day. All right. Share some things about A-level subjects. What are you thinking about, MZ? So I did maths, chemistry, physics. Out of those 3, which one did I find the hardest? I found chemistry the hardest out of all of those 3. To be fair, physics and chemistry are both big step ups. They're a big step up from your GCSEs. Okay, there's so much more to learn. So I'd only suggest doing those A levels if you're getting like the top marks. If you're getting 7, 8, 9 in those subjects. If you're getting 6s and 5s, you might struggle. It's tricky. It gets harder. So if you're not getting those top marks now, then you're going to find it hard at A level. What time on Sunday? Is going to be 7:45. You want to pick physics but can't decide on econ. It depends what you're thinking to do for uni. It depends on what you're doing, and it depends on what your other 2 topics are. So physics, if you want to do like engineering or something, then physics is really good for that. Econ, if you want to go down the finance route, econ's probably better for that. Were they hard? Yes, they were hard. I'm not going to lie. A levels are a step up, but if you get your work done, if you keep up with your work, then you can smash those grades. Yeah, it's a lot of work, but if you keep motivated and you stay on top of your work, then yeah, you can get those top marks. Oliver says, why, when a compound is an anion and cation, so has a full outer shell of electrons, why does it react with other elements if it's stable? I don't understand this. Good question, because yes, they're stable, but when they react, you can do 2 things. It can either be an exothermic or endothermic reaction. Exothermic reaction means the bond they form in the products are even more stable than what they had before. So they like to do that. That's energetically more favorable. So they decide to react. For endothermic reactions, they react because you're heating it up, you're providing the energies, and you're forcing them to react. So that's why, even though they're stable with their bonds, they still undergo reactions. That is a really good question. Oliver. Nav got 4 marks in maths. Did he? I didn't know that. That's impressive. That is really impressive. I didn't get 4 marks in maths, no, but I got really high marks. I got in the 90%, but not 4 marks. But yeah, normal maths is I found that the easiest out of the 3. But chemistry I found the hardest. But now when I teach chemistry and physics, I actually find chemistry easier than physics. I think it's probably because of what I did in uni. We did a lot of chemistry there, and I just got really good at it after that. But yeah. Oliver says, is it not to do with the dipoles making one more negative and the other one more positive? Dipoles, so that's you don't need to know about dipoles for GCSEs, but for A levels, it really depends on what type of molecule it is. If it's ionic, if it's covalent, then yes, but it also depends on what type of covalent there is. Because I'm going to get really, I'll get really technical. It's like it's to do with this is like A level chemistry. You're asking me, you don't need to know about dipoles, but the reaction between dipoles is a type of reaction you can have. You do it in organic chemistry. It's something called electrophilic addition, but you don't need to know it for GCSEs, Oliver. Is that something that you've learned in GCSEs? Just curious. No worries, Phil. You're welcome. I'll see you on Friday. Yeah. Oliver, I'll just answer your question and then I think I'm gonna head off after that. So just to answer that question and then yeah. You moved on to A level. Are you an A level student, Oliver? What did I get for A level chem? So we didn't have A stars back then, but I got an A. You're a GCSE student. Okay, fair enough. Yeah. So I got an A, which was the highest that you could get back then. It was the equivalent of A star, if you look at the percentages. But yeah, you can let me know if you have any other questions. Then drop an email and I'll reply to you. But yeah, better luck next time. Thank you for the live, guys, and have a good evening. Bye. Thanks, Oliver. Bye.